So completely serious and not empty threats aside, let's go ahead and get started. This used to be squeakier, I'm pretty sure. All right, I'm stuck already. Help.
You find the height of the church plus the steeple with the 43 angle.
Okay, so let's find everything. Now, my natural is to call this Y, but I think that here there might be other reasonable options. And it doesn't really matter what you name it. X feels just morally wrong. Maybe T makes sense for the total height. Y is what I would check. Any preference? How come X is morally wrong? Yeah, because it's moving vertical. But okay, so I'm going to call this Y. So now what Addison just said is she said, what?
So find the height of the steeple and church together using the 43 angle.
Okay, so love it. If I'm looking from the 43 degrees and I'm pretending like I didn't hear or know what it is yet, if I'm going from this is going to be the argument of something tricky. It's going to happen. Here's the angle that I'm working from. What I'm trying to find side Y, right? Which is what with regard to that angle? Opposite, and I have the length of the what? Opposite and adjacent says what trig function must this be? Indeed. So we get the tangent of 43 degrees is equal to opposite is y and adjacent is 65. Now, I noticed it just now that I wrote this as 65 degrees. Definitely not a degree. So I'm going to fix that to feet with either an apostrophe or I'll just write out feet. Apostrophe is fine. Okay. I want to solve this for y, and I want you to be able to solve this for y. To do this, there's one step away and one calculator away. What do I do?
Multiply both sides by 65.
Okay, right stat now, I want you guys to go ahead and multiply both sides by 65, and I want you to ask your calculator, what is 65 times the tangent of 43? And I'm going to give you a moment. Is yours already in a bag somewhere?
Sorry, I'm done.
You're good.
I don't think I need that unless I didn't read it later.
I need to go through all these and order like a million batteries, but I'm gonna let you guys share this one for now. If that's cool. Okay.
I'm trying, I'm really trying. I just swallow water upside down.
Why?
It helps, I think.
Okay. I thought you meant that's what gave you the hiccups.
No. If that worked, I'll be so happy. Didn't work. Unfortunately. Anyone feel free to scare me.
I want you to know the whole time I was messing with the calculator was just to get that all of it.
I was like, what is he changing? I had no idea.
100%. It was just for that little bit. Okay, I'm expecting 2 answers, and I want you guys to shout them out. We're going to go do 10 thousandths if we need to, which is how many decimals? 4. So I'm on approximations, and I'm expecting 2 wildly different answers. Somebody give me one of them. What's the number after the 5?
I don't know.
What?
It's 4-8, but she rounded.
1, 3, 5, 4, 8?
Yeah.
Okay, I just make sure it rounded. Somebody else got a very different number, I would guess. Nobody got a different number? So all of you 0.7s, where did they come from? Okay, so we'll get there. Okay, so I'm okay with this. That's feet. Do you guys agree with that? Okay, well, that's everything, right? And it's label, if we have it, is clear here, I think. But we can say church and steeple. So church plus, now instead of a steeple, because this is a shorter word, have you guys ever seen spire? A spire is just the pointy tip at a building. So it's essentially the same thing for these purposes. It's just a smaller word. Church plus spire or steeple. Okay, now I need just this though. We know this whole length. Well, what if I wanted just the steeple or just the spire? I've overcounted a bit, right? And in fact, I've overcounted a very specific amount. What is this representative of? the church. Could we find how tall the church is? Okay, so are we going to use 43?
No.
No, we're going to use the angle and the triangle that forms it. So and we'll do it the same way, just thinking it out. Now, I don't usually write my argument first, just so you guys know. I look at this angle and I say I'm finding the opposite, and I have the adjacent, right? So let's just pick a different thing. What do you want to call this? We could call it Y again, but it could be misleading. C is a natural choice for me. Why C? It's the church. Cool. So if we take this angle, I have the opposite side is the height of the church and the adjacent. And let's knock it out. What is going on here? Let me look at this because we're just going to turn the pressure scale all the way up, maybe. That seems to work. All right. So for this one, we get Y. What am I doing? Don't remember. Tangent of what angle are we going from? And I want you to be more specific because that was intentionally. 35 degrees. That's an important thought, whether we say it every time. Is equal to what if we go from that little 35? C over 65, which means C is exactly equal to how many times the tangent of 35? 65.7 people. I want you to take that 0.7 number that you got and multiply it by 65 and let me know what you get. The church is approximately how tall? 45.5. Can you give me 3 more? 35 feet. Okay, so back to our picture. If we label everything, awesome. It's going to be immediately clear if you struggle with this. If I know that this distance is 45.5135 feet, and that the whole distance is 60.6135. Interesting that we have a lot of the same numbers there. Feet. How do we find just the steeple? Somebody said it louder. What? No. Yes. I still don't know who said it, but you're whispering. Subtract. I'm just going to take 60.6135 minus 45. And it looks like we're going to get 14 point something. 15.1. Okay, so check it out. First thing that I want to notice, is this how I'm going to get full credit for this problem? No, I need a context. Now, including the label is a good statement here. What should the actual sentence read? The steeple is about 15.1 feet tall. All right, boom. Look at that. Lazy sentence, but clearly understanding the context. Are these wildly challenging? Fair. All right. How many of you guys have ever been to the ocean?
We live one?
Yes, you all have, first of all, obviously, right? How many of you guys have been on a boat?
Yeah.
Okay, you guys have all been on boats here, I assume. Is that true? Anybody not been on a boat in the waters near Alaska? You've never been on a boat around here?
You have.
Okay, so check it out. Let's say that we got on a boat, and if you haven't yet, if we were to leave the small boat harbor and we wanted to go like over to Hog Island, you're going to tell me probably, like you're going to say point over there, go toward, and we'll pull up the map in case you don't have a good idea of where we're at. Here. Oh, I would have jumped scared if that went to me. Map.google. It might be google.map. Okay, that can't be true. Maps.google. My bad, internet. Okay. Whoa. Okay. Still okay. All right. Do you guys have a good understanding of our island, do you think?
No.
We're tiny compared to the actual island.
So do you have a good understanding of Unalaska?
Yeah.
All right. So here is, I'll even switch so we can see satellite version instead. Here's my cursor. I want you guys to tell me how to get to the small boat harbor. Here's us.
We're tiny.
So, yep, the new boat harbor. So we crossed the bridge. So here I am. I'll go by PCR. Say, what's up, Salmon? We'll go past the post office. Here we go. Bridge to the other side. And I turn. And we're here at the new boat harbor on Little South America. Why is it called Little South America? What does this kind of look like as a continent?
Oh my god.
Holy cow, it's not just a name, it's little. So I'm going to blow your minds one more time. What do you call the big mountain that's pyramid shaped over there? Right, okay. Okay, so was that a realization just now too?
No.
Like that one's obvious, I hope. If you didn't have the realization that Pyramid Mountain looks like a pyramid, it does. Okay, so here we are, we're at the boat harbor. And if you know like this island well, can you tell me what this is?
Oh, that's
Captain's Bay.
So this is Captain's Bay. Like back here's where that boat is in the water, right? It's somewhere back in here. There's that
that's OSI.
wrecked boat. So OSI's here.
That's
Or here. That actually might be OSI. This is westward up here.
yes.
So we have like all this stuff. So if we were to leave the small boat harbor and it's reasonable here, you would like, if you were steering the boat and you had no idea where to go, somebody would say, yeah, go toward westward. You might just point to say, go here, right? So we leave the boat harbor and we're trying to get to Hog Island. I head this way to get around all these rocks that are here. And then where do I turn? So I turn back toward Captain's Bay. And then you might say, point to the pass, right? So then we'll go around through here. And then all of a sudden we're going through, and we're pretty much at the S-curves. And then you would just say, go to Hog Island. And you would just point to it, right? Can we all agree that we would just use like local landmarks to discuss these things? Okay. If it were dark and you couldn't use the landmarks, it might be a little bit harder, but there'd be light and stuff, right? Now, let's say hypothetically, instead of being there, we unfortunately did not plan well. We didn't file a float plan. We capsized our boat and we hopped on an emergency dinghy. And we're here. And I want you to tell me how to get home. You can't say go toward the road, or you can't say go toward the bay. You're going to have to be very precise with how you tell me where to go.
Something stars degrees.
So I'm okay with stars. Like if we're wayfinding, that's okay. Like realistically, I don't know how to wayfind, so I couldn't do it. But we wayfind because, and how we do it is there's one star that no matter where you are on the planet, it points the same direction in the sky. The North Star. We have a way to identify north on our planet. Now, if you had some magnets and stuff, you can make a compass. But if I didn't have this compass, if I just said go left, left doesn't mean anything, right? Unintentional direction thing. But it means nothing. It's just like if you're in space and you say go up. With respect to what? Because there's no direction that's up or down. It just depends on where you're looking. But somebody said the stars, and then I heard something else back here.
Like something degrees.
Oh, degrees. Now, check it out. This, if you ever wind up sailing in deep water and you need a way to get around and your GPS has died, this is a natural way to progress into it. We are still in 4.8, but we are going to pivot. We're doing application problems, and this is still going to be applied stuff, but we're going to talk about bearings. Now, bearings, all that these are is a way to give direction when there's no like visible reference. Now, the way bearings are handled varies depending on the type of vehicle you're driving. Nautical or boat bearings are very different than airplane bearings. Now, we are going to use nautical bearings for ours. So we'll just even put that in here, nautical. Which when you see nautical, do you know what we're referring to?
See.
The sea, the ocean. Okay, while we're looking at these, we're going to look at a few different angles, and they don't have to be perfect, but let's say that we are working, and we're just going to draw some pictures here, and then we'll get a nice definition if we need to. Okay, if we are mixing the world of Precalc and the world of sailing the seven seas, I want you to estimate this angle for me. And it doesn't have to be perfect, but if I said let's estimate this angle, where roughly? So I heard 60, 70 maybe. Let's go 75. Somewhere in that range. Now, do me a favor. I want you guys, once we get this, I want you to stand up for a moment. Everybody's going to stand up for a second here. All right, and I want you to do this. And Brett, I want you facing that way. I want you facing me. Everybody look at different direction than your neighbors. And here's my challenge. On the count of 3, we're all going to turn roughly 75 degrees. Ready? Should we make it easier? Make it 90? Cool. Check it out. Everybody turn 90 degrees. If my directions to you were to turn 90 degrees to get home, are we all correct?
No.
We're all
Yes, but
facing
no.
different directions, even though we all turn 90 degrees, right? Do you agree that there's a shortcoming with using that as a way to talk about direction?
Yes.
So if I said turn 75 degrees, it's a little bit harder, but it's like here-ish. But depending on the way you're facing, it changes, right? So if we want to remove that ambiguity, which we should, we're going to do the following. We're going to use bearings. And we'll use this as our first example, but these are simply amount of angle. So we'll just say angle from north or south. Not of south, north or south. Now, for our purposes right now, 75 degrees, if we're talking unit circle stuff, we know it's positive x-axis and up. On this, if we're looking at any map ever that's drawn in a kind of standard way, what direction is this? Up, typically on a map. North. What's over here? So somebody didn't look. West. Down? And to the right. East. Purely out of curiosity, how do you guys remember these? I already heard somebody say never eat soggy waffles.
Yeah.
Anything else?
No.
Okay. Everybody spits at Washington, nerds, right? I don't know. I'm just making up nonsense stuff. Everybody thinks never eat soggy waffles or sour watermelon. Okay, check it out. When we're thinking about these, we can go from north or south. Now, you could talk about bearings from other directions, but it'd be a weird thing to do. Nobody ever does it. All we need to look at when we're trying to work these out is, are we closer with our terminal side? Is it pointing more north or more south? Is this right here more in the northerly direction or in the southerly direction? If you're not sure, looking at this, do we all agree that I definitely went more toward north than I did south? Okay, so when we have these, we're always going to say from north or south. So we start at north, and then we're going to clean up this notation here in a second. We start at north, and then we turn. If I started at north, so now I'm like looking right here, which direction should I turn if I want to go to that angle? Toward the east or toward the west? So I go north, and then I turn some amount of degrees to the east. And I left a blank here. How many degrees to the east needed we turn? Must we have turned? Weird. 15? So do you guys agree that if I wanted to be very clear, I could say start at north, face north, and then turn 15 degrees west? Or east, in this case, rather, sorry. Would we all guaranteed be facing the same direction as long as we know what true north is? Okay, this takes that ambiguity out. Now, we always work from north or south. You could, it'd be weird, but you could say start at east and then turn 75 degrees which direction? If I started here instead, I'm now turning 75 degrees to the north. That would be correct, but it'd be a really weird way to do it. We start at north or south. The way that we shorten this, and this says start north, turn 15 degrees west. That's like an example of a bearing. The way that we actually write these, though, will be simply north, and then we turn how many degrees? 15 degrees to the what? Here is our true bearing. This is red, and you can say it exactly like we did. Start at north, turn 15 degrees to the east. But language-wise, we want to be able to talk about these things. This is read very differently. And I'm going to wait until you guys get this written here. The way that we're going to say these is not N15E, which is physically what we write down, but this is 15 degrees east of what? East of north. And now we have a bearing. And my grammar and English maybe shortcomings are showing. I don't think that east and north are proper nouns. This whole time I've been writing them cap. No cap. I've been writing them with that. I don't think they're actually capitalized, but I'm going to capitalize them. Are they?
Yeah.
Cardinal directions, proper nouns?
No, they're not. They're not. I think they are.
I mean, I'm sure that Kanye's kid's name is certainly capitalized. Isn't his kid's name's North?
West, Northwest.
So dumb. I didn't say that. Okay. Cool. I want you guys to sketch some angles. Angles. You're going to eyeball some bearings for me. Okay. So we're just going to work with the assumption that up is north. And you're going to sketch me some bearings. So on A, and really roughly sketch, I'm fine with it. I want you to do south 30 degrees W is what I want you to sketch. And then on B, I'm going to give you one more. And let's say north, we'll say 80 degrees west. Cool. I want you really roughly sketch out these angles with the assumption that north is up on the coordinate plane. If you're struggling, I'm not just getting my steps in. I will help you. I'm happy to help. Want to help, but you gotta ask. So love this. What do you? So we don't need for this. We're just working with the assumptions because we're doing there. Where's the actual?
I don't know what's trying. No, it's
If you start at south, then you just turn 50 degrees west. Yep.
Oh, that's right.
I
Love
get
it.
it. In my own way, yes.
Okay. Checking these out. And I just wanted to make sure because we got a really cool problem coming up soon. Okay. Looking at this, do we need a little bit more time or are we okay? All right. So here's my coordinate plane. If I want to do this bearing, first and foremost, anybody want to volunteer to read it out loud before I just call somebody? Okay. We're just going to do the calculator then. Karina, how would you read this?
30 degrees west of south.
Love it. That means I start at what direction? South. So here's me facing south already. If I'm going to turn 30 degrees, do I need to move to the left or to the right? To the west would be to the left, right? Now I'm just eyeballing it out here. Would you believe that's about 30?
Yes.
So if I have this, here is my bearing. This is the direction that I'm going. Here is the angle that we're actually given. Now, I can give you this bearing. Is this the angle if we were doing Triggy stuff that we'd be working with? Where does our angle that we're working with, and this is why I didn't quite address your question, where does the angle that we're working with actually start? It would be this whole angle that we would plug in for stuff, right? Now, we get the bearing, and this is the actual angle that they give us, but we might have to work with the other bigger piece to really get the true sines or cosines and those things out of it. Okay, this one, what direction do I start? North, and then I fall to the west or to the east? I fall to the west, and you tell me when to stop falling. About there, right? And it messed up, so I'm going to do that. It's a tiny angle here. This is my 80 degrees. What if I said, what's the angle in standard position? Which means this big part. What is the big angle here? 170. Love it. What's my theta prime reference angle if I wanted to use a reference angle? The acute angle between this terminal side and the x-axis. 10 degrees. And then we could think quadrant 2, and then we have all of our same stuff. Everything that we've seen ties back together, and it will still work. Okay, should we do a boat problem? Good. I don't know why I'm so aggressive with that. Do you need a brain break before we do it?
Yeah.
Too bad. All right, what's the coolest winter sport?
Curling.
Ice skating.
Okay, talk with your neighbors. What's your favorite Olympic sport in general? Does not have to be winter. It can be any Olympic sport. We'll go 60 seconds. Talk it out. Do you really know who won? Between Italy. So I have a guess too, because stupid Peacock says, would you like to watch this game tomorrow? It's like, dude, I'm watching replays. Why would you? Anyway, here we go. This one we're going to write down. Example. And we're just going to call this boats. And this might be the last example that we have right now. So here we go. I am going to make this as light writing as we can. So you're at the pier, and we're just going to work with that assumption. And you're at some dock. Here we go. Hop in a boat. And we're going to head due west. DUE is the due part, and we'll talk about this. Due west at, and then I'm going to write this out, 16 KTS.
Knots?
Love it. And we're going to, gosh, there's so much history in these. What's a knot?
Speed.
It's a speed. It's nautical miles per hour because on the middle of the ocean, it's hard to tell how fast you're going, right? So the way that you could do this, if you wanted a standardized way to talk about your speed and GPS isn't a thing, is me and all the other sailors at a pier somewhere could say, hey, do you guys have a rope? Of course we do, right? We're sailing boats. We'll say, hey, let's all tie knots in this rope so far apart. And we can all have the same rope. And then when we're sailing in the ocean, if we want to know how fast we're going, it's not going to be miles, right? Because we don't have a way to measure the nice distance because there's no way to check where you're comparing it to. But if I'm moving in a boat and I throw a rope overboard and I'm actually moving, is the rope going to keep coming out?
Yeah.
And if I said, hey, I want to count how many knots of mine go into the water over some amount of time, could we do that?
Mhm.
And if we all agreed to just do it like every minute, if I said there's 7 knots per minute falling out of my boat, and yours was 8 knots per minute, and we tied them at the same intervals, who's going faster? 7 knots come out of my boat, 8 knots come out of hers. She must be going faster, right? So that's where this wind speed and speed comes from. A nautical mile is pretty close to an actual mile nowadays. I don't know the measurements off the top of my head, but this is a speed, nautical miles per hour. And we'll go ahead and sneak that in here. And maybe the history isn't the most exciting part of this. Just going off of Addison's vibes here.
No, I'm just tired.
You do not offend me if you think that my history lessons are boring. I'm not a history teacher. Okay, so we hop in a boat and we head due west at 16 knots. Now we get a magic boat that is immediately going 16 knots. We don't have to accelerate into it. We're just working constant speeds. Okay, more magic to this. After 30 minutes, our magic boat turns instantly, which means there's no curve to it. It's like this is what's happening, but it doesn't really happen. We're going, constant speed. Going, constant speed. So we're working as nice of a problem as we can right now. But after 30 minutes, we change to, well, this is ugly, S33 with that symbol with a W. At 18 knots, nautical miles per hour. Here's what I want to know. If we do this, if we travel at this bearing, for 45 minutes, how far from home are we? And I'm going to say the dock. And I know that's the first mention of a dock. Are we? Now, I could ask at what direction would we need to go and all that good stuff. We'll probably do an extension of just thinking about that. But we have a very specific bearing problem here. And at 30 minutes, maybe we have lost all sight of land. 30 minutes probably is not enough time if we're only going 16 knots realistically. But we'll pretend that we can't see anything, so we need to talk about directions like these. Would a picture help? For sure. Now, the first thing, just because if you've never seen these languages, maybe, if I say due west, what does that mean?
Going west.
What do you, so I agree, but why didn't I just say west? Why did I specifically say due west?
That's where you're supposed to end up.
Mm, kind of. If I'm right now, do you guys know which direction west is from here? Anyone know which direction north is? Point toward Ballyhoo.
I don't know what
What?
it is. Huh? I don't know where
I don't think Ballyhoo's that way.
I don't know where Ballyhoo is.
Like
I don't remember where it is.
Ballyhoo's like over there.
Yeah, I felt like.
So we're pretty close to north right here. If that is true north, west would be left, right? So I would turn 90 degrees. Am I pointing exactly west now, theoretically? That is what due west means. Like straight along, like perfect west. So at 180 degrees would be the big angle. Okay, so for this, we're going to draw that, and we're going to have to do a little bit of math here to work this out. So because I know I have to go west, I think I'm going to leave some space to go west. Now, good thing to have on problems just generally. North, south, east, and west will include our little compass. What is this called? Compass rose. Cool, cool. So we have it, and here we go. I go due west. Now, I'm looking ahead at where this problem goes. We're going to turn magically here. Here's the first leg of our trip. My first question is, do you know how long this side is? Or how far have we traveled, I guess? So we have traveled for 30 minutes, but we definitely haven't gone 30 minutes away. Like, I mean, we have, but it's also not 16.
8 knots.
Why would it be 8?
Because it's 16 knots an hour, and if you did half an hour, it's 30 minutes. 8 knots.
Yeah, we were going 16 nautical miles per hour, but we only went for half an hour. We've only gone 8 nautical miles. Okay, so I'm just going to label this 8 right here.
I don't understand how you got that.
If you're going 60 miles per hour for 1 hour, how far do you go? What if I said you went 60 miles per hour for half an hour? What if I said you went 16 miles per hour for half an hour? Not so you're gonna feel silly when you have this realization, which not in a bad way. How did you know that you only went 30 miles before? So if I went 16 miles per hour, we'll call it, for half an hour, what's half of that? Yep, we just went for 0.5 of an hour. Distance times, or speed times time will give me distance. And because you did the 31 just in your head, it feels different, but it's not.
I understand.
Okay.
I don't know why.
For this one, I would strongly encourage light drawings because all of a sudden I turn, right? And when I talk about how we turn, I give it to you in a what? What does this say? And that's a bearing for sure, right? Now, I don't want my picture to get awful, but I also want to be able to make sense of it. Can you guys see that faint line?
Yeah.
Okay. I'm going to draw a faint line that lines up with east, west, north, south. And this is going to be really faint. I don't want it to show up in my whole, like, I don't want it to stand out when I'm doing it. But I need this to be able to say how we're turning, right? Now, if you eyeball it out, you'll be okay. But I do honestly think this helps. So I turn and I start at south and I go 33 degrees. Which direction? West. Is that to the left or to the right? So I'm going to eyeball it and you guys just help me. And it doesn't have to be perfect because I'm going to label it. 33 degrees. I don't know, there-ish.
Yeah.
A third of the way through. So here's my 33 if we want to label it. There's my 33 degrees right there. And I'm actually going to make it bigger, but I'm just going to draw it from out here. There, just because I don't want it to muddle up the rest of my picture. Are you guys cool with that? 33 degrees is between south and west. And then let's work out this length. I'm going how fast on this second little part? 18 knots. So I sped up and I'm going for how long? 30 minutes? 45. So 45 minutes is how much of an hour? Everybody agree with that? It's 3/4 of an hour. And if I've gone 18 knots in 1 hour, what's 3/4 of that? Is that a calculator number? You just did it in your head? Okay. Can somebody second 13.5?
Yeah.
Okay, because half is 9, right? We just add 4.5. Okay. Now, the question asks, what? How far from home? Now, is my picture to scale, first of all? No. Does it matter? No. I want to find this. That's what I'm after. Now, there's maybe an issue that we have with it. Maybe. Oh, man. I want, before we do this together, I'm going to give you guys like 3 minutes. I want you to talk out strategies. If you think you see a way through this problem in this non-right triangle, to use SOHCAHTOA stuff on a non-right triangle, just specifying for some reason. 3 minutes. I want to see what you guys come up with. If you get an answer and you're confident with it, I have a follow-up that I want you to answer. I don't want just the distance. I want you to tell me what bearing should I follow to get back to the dock if you get this answered first. We are looking for this length.
So SOHCAHTOA only work on right triangles?
SOHCAHTOA will only work on right triangles. To make sure that everybody can hear it. Addison asked a really important question, and I commented on it multiple times before we did this. If we want to use SOHCAHTOA, what do we need? A right triangle. Now, is there a right triangle on the board? I mean, you could say yes, and I agree with you. Now, this little angle here, you guys, did anybody go through finding this? If I claim that this is 90 degrees, can we all agree that that's true? It's because it's where that's where my coordinate meet, right? Like there's where I drew it. Now, here's what I'm going to suggest. It is natural for us to look at this problem and say, oh yeah, let's use the fact that this is 123. And if we do that, does it give us a right triangle? No. So what I want to do is we're going to make a little comment and we're just going to maybe make a claim here. We're going to work this way and we're going to do one more little sketch. This, I don't know that I really agree with this, but right triangles are the right choice here. Now, there's obviously an intentional play on words here, and I'm not trying to confuse you, but I do think that right triangles are the right choice. If we want to use SOHCAHTOA and we don't remember exactly how to use the law of sines or the law of cosines from geometry 2 years ago, then we need another way to do it. Now, there's a couple different ways that we can make right triangles show up here. Do not commit to one until we decide which one's nicest, okay? The natural thought is to just do this. And now this is a right triangle, right? And that's all fine and dandy until you realize that, awesome, we have one right triangle, of which I know one of the sides and one of the angles. And then SOHCAHTOA doesn't take us anywhere. Pythagorean theorem isn't even at play, and we're just kind of stuck. Okay, so that triangle is a natural choice, but maybe it just doesn't work. Now, in geometry, do you guys ever remember adding or extending lines to stuff? Now, they're called auxiliary, and you probably don't remember specific situations. But if I take this exact same triangle, exactly as we have it, and I was wondering why it looked weird, but it's a pencil. So we'll make this bold. And I'll even put the lengths on here still, 8, and this is 13.5, right? I'm going to put it inside, and I would suggest you guys should as well. Like, I want you to redraw this, and you'll see why here in a second. 13.5, and we can highlight the same thing. I'll dash it. That's what we're after. And could we call it something for now, just so it's not just some question mark? What do you want to call it? D is my natural choice for the distance here. Anybody opposed to that? Okay. We still don't have a right triangle though, right? So let's see if we can do it. That was 13.5. Well, can I pretend like due west had kept happening until here? At which point due south happened. So I'm going to actually not just do it like that. I'm going to just extend it and I'll dash it. By adding these auxiliary lines, my extra lines that weren't there naturally, have I changed any of the information on my graph? Or on my picture? No. But have we made something awesome happen? We now have a big triangle on the board. What's this angle?
90.
And then let's just see if we can't. I'm going to give you one more hint and just see what we can come up with. What was this angle on the inside?
123.
So that was my 123 right here. With what we have on the board now, by extending this out and the fact that we have a right triangle, do you think we can find it? All of a sudden, it's not even the big triangle I care about yet. I want you guys to continue working. This is the triangle that I'm going to focus on, at least for now, because I have an angle of it. I haven't written it, but I do have an angle of it. I have a side of it, and I can find the other sides of it. Cool. I want you guys to, let's try to finish this problem before leaving today. And then tomorrow, we'll have a curated list of super fun problems to work through in class that'll segue naturally into our practice test. I don't want to bum you guys out. Are you guys getting out today, do you think?
I think we will.
Good.
No, I think
I hope you do.
Thank you guys. I appreciate the encouragement because everyone's telling us we will and it makes me so
I mean, it looked windy today, but there's windows. Like, cool. I hope you do. In the nicest way possible. I do not want to see you this week. Okay, guys, I'll tell you your homework is to finish this problem, and I'll check with you guys to give you the answer before you leave, just in case you're not here tomorrow. Cool.